All right, let's do our example problem here uh, for for density. So the equation for density is rho equals m over v. So it's capital V for volume, not lowercase v for velocity. Okay, it's mass, normal, lowercase m, and that's not a p, it's the Greek letter rho, and it's what the symbol is for density. So what's the mass of an iron wrecking ball that has a radius of 18 centimeters? A volume of a sphere is 4/3 times pi r cubed, and the density of iron is 7.8 times 10 to the third kilograms per meter cubed. So when you plug in the number, you can plug it in as 7,800 if you want. That's not usually how we write it. We usually write it like this, just to make it uniform when we're comparing the numbers. But the setup's pretty straightforward. You plug in the density for iron. Mass is what we're solving for. 4/3 pi r cubed. Notice that my radius needs to be in meters, not centimeters. Plug the numbers in and solve. Get an answer for m, and that'll tell you how to solve for the example. So when I'm solving it here, again, be careful about order of operations and all that stuff. So I'm going to go ahead and do the bottom first. So it'll be 0.18 squared times pi, and you can do 3.14 if you need to, times 4/3. Gives me a very small number. I'm going to multiply that to the other side. It's in the denominator, so I just found that whole number. I'm going to multiply that to be the other side because it's being divided. So 7.8 times 10 to the third. Make sure you're doing that in scientific notation. I get 1,058.6. Okay, there you go. Pretty straightforward on solving density problems.